Hello juniors, today we're going to see functional notation. The objective for today's class is to express relations using function notation. So what is function notation? It says, when writing an expression for a function, there are several different notations. For example, f of x or g of x, or also f of x written this way. These are all called functional notation. F of x said as f of x represents a function f with independent variable x. So the x inside here is our independent variable. Then it says, we use functional notation instead of just y equals something to be able to distinguish between different functions, in the same way people have different names. When dealing with a real-life problem, the functional notation can be customized for the variables. For example, the relationship between the number of tickets purchased for a football game and the total cost could be represented by Cn. What do you think C and N stand for? Well, in this case, C is the total cost, right? We're talking about the total cost. And N is the number of tickets, right? Number of tickets purchased. So you see how we can customize the letters depending on the problem and the situation we're analyzing. Functional notation is a quick way of expressing substitution. Rather than saying given y equals 3x minus 5, find the value of y if x is equal to 2, we can simply state given f of x equals 3x minus 5, find f of 2. F of 2 means find the value of y when x is equal to 2, basically, right? So let's see some examples here. It says, calculate the substitutions indicated for each given function. So we have this function g of x expressed in this way. G of x are the set of numbers or the set of ordered pairs 2 and 3, 4, 5, 6, 7, 8, 9, 10, 11. So if we want to find g of 8, basically what we're looking for is the value of y when x is equal to 8, right? And if we look for when x is equal to 8, the respective value of y is equal to 9, right? So for part A, we would say that g8, or the value of x, or the value of y when x is equal to 8, is 9, right? Directly like that. Then for part B, it says f of x is equal to negative 2x minus 1, and we want to find f of negative 3. So this basically means what is the value of y when x is equal to negative 3. So we would say that f of negative 3 is equal to, and basically what we need to do is replace this value of x into our function, right? So this would be negative 2 times negative 3 minus 1. And if we solve this, we're going to get that f of negative 3 is equal to, this is 6 minus 1, which is 5. So that's f of negative 3. That means that the value of y when x is equal to negative 3 is 5. Then for part C, we have f of x equals 3x plus 7. Find f of 1. So same thing here, but now we have a different notation, but it's basically the same thing. If we want to find f of 1, we just replace the value of x for 1, and we get 3 times 1 plus 7. And 3 times 1 plus 7 is equal to 10. So that's f of 1. It's equal to 10. Then for part D, it says h of x is equal to 3. Find h of negative 1. Okay, this is a tricky one. Because take a look. If h of x is equal to 3, you see that there's no independent variable here. There's no x right here. So what would be the value of h of negative 1? When x is equal to negative 1, what would be the value of y? And we would see that h of negative 1 is still equal to 3. Why? Why? Because there's no x, right? So it doesn't matter what value of x I input, the output will always be the same, will be equal to 3, right? Because there's no x in my function. And this is the case for a horizontal line, right? We're going to analyze these functions later on, but you should know that this is a case of a horizontal line. The value of y is always constant, and it doesn't matter what value of x we input into our function. The value of y will always be the same. Finally, for part E, Let me write this here. This is a horizontal line. And for part E, we want to find f of 4 for the graph. So f of 4 means the value of y when x is equal to 4. So if we take a look at x equals 4 is right here. So the value of y is this value over here, which is 5, right? So that's what we need to do in order to find f of 4. So just by looking at the graph, let me write this here, we would say that f of 4 is equal to 5, right? That's the value of y for x equals 4. Okay? So I think this is clear, people, right? I'm going to leave this here just for you to understand. Okay, so that's it for this first part. Let me frame these results there and there. Now let's move on to other examples. It says, if f of x is equal to negative 3x squared minus 1, find, and we have different things, right? We're going to start with a, f of negative 1. So if we want to find this, it's directly plugging in the value of x, right? Negative 1 squared minus 1. And we solve this. So we're going to get that this is 1, negative 3, negative 4, right? So f of negative 1 is equal to negative 4. These are easy problems, right? Just for you to understand functional notation. Then part B, f of 0. Same thing, right? We replace the value of x for 0. And we're going to get negative 3 times 0 squared minus 1. So f of 0 is equal to negative 1. That's it. Then C, if we want to find f of 100, we're doing the same thing, right? Negative 3 times 100 squared times 100 squared minus 1. So f of 100 is equal to 100 squared, that's 1,000, no, 10,000 would be right. It's negative 3 times 1, 2, 1, 2. Yes, this is 10,000 and minus 1. So this is equal to, I'm going to do this here, negative 3,000, 30,000 minus 1. So we're going to get that f of 100 is equal to, this would be negative 3,0,0,1, right? This is a value of f of 100. Then for part D and E, let me do that in this column here. F of A, so we're now plugging in a letter. So it's the same thing, right? F of A would be negative 3 times A squared minus 1. So the answer would be left just as it is, right? Negative 3a squared minus 1. We cannot do anything else here, so we're going to leave it like that. And finally, for part E, it says f of x plus 1. So instead of writing x, we're now writing x plus 1. So it's the same thing, minus 3 times x plus 1 squared minus 1. So if we expand this expression, we would have, do you remember how to expand a squared binomial? It's, let me do that here. We're going to write negative 3, and it's the square of the first term plus 2 times the product of the two. So 2x times 1 would be, right? Plus the last term or the second term squared. 1 squared minus 1. So if we organize this, this would be negative 3x squared minus 6x minus 3 minus 1. I hope I'm not making any mistake here. So this is negative 3x squared minus 6x minus 4. And this would be f of x plus 1. Right? This is our final answer for this exercise. Okay? I hope this is getting clear for you people. Let's move on to this example, which is a word problem. It says, the formula to calculate the volume of gas left in a car's tank in liters after traveling d kilometers is volume with respect to distance is equal to negative 0.115 d plus 60. So for part A, it says, explain what V of 250 means in the context of the question and calculate its value. So what would be V of 250? Basically, it's the volume of the gas after traveling 250 kilometers, right? So let me write that down. Volume of the gas left after traveling 250 kilometers. I'm going to write this as km only. So if we want to calculate that value, we would say that V of 250 is equal to negative 0.115 times 250 plus 60, right? We will need to use a calculator for this, so you can grab your calculators and make this calculation on your own. I'm going to do it here. So this is negative 0.115 times 250 plus 60. I get 31.25, and the unit of measurement is in liters, right? So this is liters. So this is the answer for part A. We're having 250. Put that right there. After covering 250 kilometers, I have 31.25 liters of gas left in my tank. Okay, then moving on to part B. Part B says the following. Explain what VD equals 10 means in the context of the question and calculate its value. Okay, so now we have that VD is equal to 10, right? So what does this mean? First of all, the 10 means that I have 10 liters of gas left in the tank, right? And what I'm going to be calculating is the distance I have covered in order to only have 10 liters left in my tank, right? So this means that I only have 10 liters of gas left in the car's tank, right? The car's tank. The distance that we will calculate indicates the total distance covered in order to only leave 10 liters of gas in the tank. That's basically what we are calculating when we find VD equals 10. So if we want to calculate this distance, we already have the value of the volume, which is 10. So we're going to set this equation over here to 10, right? So this is 10 is equal to negative 1.115 D plus 60, right? So if we solve for D means leave the D alone. We would have negative 50 equals negative 0.115 D. And then if we calculate this using calculator, we're going to get that D is equal to 435, if we round it to the nearest integer number, kilometers. This means that in order to only have 10 liters of gas left in my car's tank, I need to start with full tank, right? And travel 435 kilometers in order to have only 10 liters of gas left in my tank. Okay? So then for part C, it says what values of D do not make sense for this situation. Interesting. So for example, Well, we would have to calculate our extreme values. Extreme values would be when I have, what is the volume of the tank when I have covered 0 kilometers, or I haven't covered any distance. Let me take this a little bit down. Just a second. Here. Okay, so for part C, if we want to calculate the values of D that do not make sense for this situation, let me write here the equation VD is equal to negative 0.115D plus 60. The first thing we can calculate is how much is the maximum volume of our tank, right? The maximum volume occurs when the distance covered is 0, right? So V0 would be negative 0.1155 times 0 plus 60, which is V0 equals 60 liters. This represents the maximum tank capacity. And then the minimum tank capacity would be when the volume is equal to 0 liters, and that will occur, and we can calculate that. We're going to set volume now to 0 equals negative 0.115 D plus 60. If we solve for D, we're going to get that negative 60 divided by negative 0.115 is equal to D. So we're going to get a value of D, which is equal to 60 divided by 0.115, 522 kilometers. That means that the maximum distance I could cover is 522 kilometers, which means, if we go back to the question, what values of D do not make sense for this situation, we would say that the values of D that do not make sense for this situation would be any distance greater than this. So any distance greater than 522 do not make sense. Why? Because we already finished our tank fuel after covering 522 kilometers. We would have to refill our tank in order to be able to keep on traveling, right? So this would be the answer. And obviously any distance below 0 would also do not make any sense, right? But we cannot talk about negative distances. I cannot say I am going to travel negative 10 kilometers, right? So that's why I do not add this into the answer and just state this, right? Okay, then we're going to see this example. It says, Nikita is planning a sport banquet. He must pay $320 to rent the room and $20 per person for dinner. Okay, so in this case, we would have to build our function, right? Express the total cost C as a function of the number of people N who attend the banquet. So our two variables are cost C and number of people N, right? This is the independent variable, and this is the dependent variable. So how can we write this equation? We would say that cost in terms of number of people is equal to, we have this fixed cost, which is to rent the room, and then $20 per person. So the equation could be, or the function could be modeled this way. The fixed cost plus $20 per person, right? Plus 20N. So this would be our function for part A. Then for part B, it says when notation could be used to find, or what notation could be used to find the cost of the banquet if 125 people attend. Calculate this value. So the notation would be basically cost of 125. And how do we calculate this value? Basically, we replace the value of N by 125. 20 times 125. So we calculate this cost and we get 320 plus 20 times 125. You can use your calculators for this as well. So I get this number, 2,820 would be the cost. We're talking about dollars, right? So don't forget unit of measurement. This would be the cost. Then for part C, let me do part C right here. It says, what notation could be used to find the number of people who can attend the banquet if Nikita's budget for the banquet is 1,250? So now I have the maximum budget, which would be our cost, right? So let me plug in that into our function. 1,250 is equal to 320 plus 20n. So now I want to calculate n, which is the number of people that can attend in this case. I'm going to solve for n. 1,250 minus 320, that's 930, is equal to 20n. So the value of n, if we divide 930 divided by 20, would give us 46.5 people. But remember, we're talking about a number of people, right? So where do you think we need to round this value? To 46 or to 47? If I have a maximum budget of 1,250, I cannot spend more than that, which means that I need to round this number down, okay? Because if I round it to 47, then the budget would be more than 1,250, and I won't be able to pay for that. So actually, the correct answer would be 46 people. Although our intuition would say that we need to round this up, but it's not the case. We always need to analyze the context of the problem in order to determine where should we round, okay? Finally, for part D, it says what values of n do not make sense for this situation. Again, we would have to calculate, in this case, let me think, the maximum cost. Well, if 0 people attend, then the cost would be 320 plus 20 times 0, which would be equal to $320. But this doesn't make sense because why would we pay for something that no people are attending, right? So this value of n does not make any sense. And then for the maximum value, I cannot think about any restriction, right? If I don't have a budget restriction, as I did in part C, then I could invite infinite number of people, right? The problem is not talking about any restriction. So I would say that only n equals 0 does not make sense. And I'm going to add, there is no restriction for the maximum amount of people. And logically, I cannot invite a negative number of people because that doesn't exist, right? So n equals 0 would be the only value that does not make sense in this problem. For the rest, you can calculate a logical value. Okay, finally, we're going to see briefly the difference between draw and sketch, which are two terms that are used a lot in the IB problems, okay? You need to know this difference because there's a huge difference in time when we talk about draw and sketch. So it says draw and sketch are two of the IB common terms you need to know. Draw represent by means of labeled accurate diagram or graph using a pencil. A ruler, straight edge, should be used for straight lines. Diagrams should be drawn to scale. Graphs should have points correctly plotted, if appropriate, and joined in a straight line or smooth curve. Basically, draw is doing a very neat drawing, right, or a very neat graph. You need to plot various points. You need to mark any. You need to mark labels, you need to mark your scale, everything should be very, very neat. While sketch, it says, represent by means of a diagram or graph. Labeled as appropriate, the sketch should give a general idea of the required shape of the relationship and should include relevant features. This is a very important thing you need to consider when doing sketch. The relevant features are, for example, maximum, minimum points, x-intercepts, y-intercepts, asymptotes, or whatever. We're gonna see lots of this later on when we study different types of functions. Okay, so here I did an example of the difference between drawing and sketching. You see that for drawing, I did a table of values in order to plot different points and have a more precise or smooth curve, right? And all the labels are here. And my x-axis is correctly labeled, my y-axis is also correctly labeled, and so on. Well, this sketch is just a quick thing, something that you can do in 2 minutes or less, which shows a general idea of the shape of the function. This is a function that I'm drawing and sketching in this case. Okay, so you see, I didn't even put all of the values of x nor the values of y, because it's just wasting time. I just put it the ones that are important, right? In this case, this value here is important because it's the vertex and also the root of this parabola. And I also plotted this point over here, which is the y-intercept of this function. So I identified the two relevant features of this particular graph, and I only plotted those two, and then I did a quick sketching of this function. So that's how you sketch. So I hope the difference is clear for you people. To finish, we're going to see these two examples of how we can sketch the following graphs. So for this part, I'm going to show you how to graph using calculator again. So for part A, we want to do a sketch of negative x squared plus 4. So let's go to the calculator for a second. If you take a look at the calculator right now, let me erase this. We're going to go to menu graph, which is menu 5. And we're going to plug in our first equation, which is negative x squared. Remember to use this x over here, not the one over here. Negative x squared plus 4. So it is selected. So that means that when we draw, pressing F6, we're going to have the shape of the parabola here in this case, right? So this is, we already have a general idea. We can change the scale in order to make it look more... make it look better, right? In order to change the scale, I can go to Shift V-Win, which is F3, and here you can define your scale. We can say that the minimum value of x would be, for example, negative 10. The maximum value, let's set it to 10. And here the scale, we can go from 1 to 1. So if I put 1, then it will go from 1 to 2, 3, 4, 5, and so on, right? Let's do the same for y. Let's put as minimum value negative 10, as maximum value positive 10, scale also 1. So maybe we should be able to see the graph a little bit better now. You see? So this is a scale of 1, 1, 2, 3, and same for y, 1, 2, 3, 4. Okay? So with this, we have a general idea of how the parabola looks like. If we want to look for key features, we could also do that in the calculator. For example, if we go to Shift G solve, which is F5, and we click on maximum value. In this case, we have a maximum value here, max F2. You would see that here we have the coordinates which represent the maximum point. Let me write that down. The maximum point has coordinates 0, 4, right? Other things that we can calculate are, for example, the roots. I'm going to calculate these roots by going to Shift G solve, and here you have root. Root is a synonym for x-intercept, right? So we click on F1. So the calculator shows the first root. Let me write root 1 has coordinates negative 2 and 0. And if we want to go to the other root, you just click on the right arrow here. And you get the second root, which is, let me write that down, root 2 is equal to 2, 0. So with this information, we can already do a quick sketch of this graph. We can do here our coordinate plane. This is x, this is y. I'm going to mark the maximum as right here. I'm going to say that this is 4. Then negative 2 would be somewhere around here, and positive 2 would be somewhere around here. So with that information, I can already do my graph, right? We have the vertex right here, one root over here, and the other root over here. So I can join these points, doing a smooth curve like this, and that's fine already for a sketch. Okay, we have identified the relevant features, and that's enough to do our sketch. Then for part B, our function is y equals square root of x minus 3. So we're going to do the same thing. We're going to go to a calculator, and we're going to erase this one. We already finished this, and we're going to do square root. Remember, shift x squared, and you get the square root of x minus 3. Click on execute, and then draw. I have 6, and here you have the graph. Maybe you can change the scale a little bit, but I think this would be fine. You see that it begins at the point 0, 3, right? No, not 0, 3, 3, 0, sorry. We can find that. We could add, we go to shift G solve, and again root to find this point over here. You see, 3, 0, right? So we can say that the starting point would be the point 0, 3. 3, 0. Sorry, 3, 0. That would be our x-intercept, right? And then we don't have any y-intercept. The graph never crosses the y-axis, so that's the only relevant feature we can take out of this sketch over here, right? So we're going to do the sketching. Again, we draw our coordinate plane. And we just need to do something similar to what we see on our calculators. I'm going to mark the point 3 somewhere around here. So let me do this. Let me do it red. We have this point here, and then we do something like this. And that's more than enough in order to do a sketch of this graph. Okay? So I hope this was clear for you, juniors. If not, please let me know, and we're going to clear doubts in future live sessions. Thank you for your attention.